Okay. Get your calculators. Load the dust off them. I probably haven't seen any use for at least a week. Okay, so the first one here, differentiate ex cos x over x squared plus 1. So ex, this is a1, ex cos x over x squared plus 1. So it's derivative of that. So I need two rules here. What two rules would I need?
Product and quotient.
Yeah, which one first? Quotient rule. So the quotient rule is the bottom squared. What's wrong, Faisal? What's wrong? Did you come to school with no pen? The bottom times the derivative of the top. And what rule do I need for the derivative of the top? That's the product rule. So that's ex cos x. That's the derivative of e, and derivative of cos is minus sine. So minus ex sine x. And then, need a bit more space here, minus the top times derivative of the bottom. There you go. That's the first one done. Don't worry, I'll go back to it. I just want to have a look at what the next one is. So x cubed plus 8x squared minus 5. So x cubed plus 8x squared minus 5 equals 0. So here they're looking at all the different ways you can write this as a fixed point problem. And in total they're looking for, they give you one example there, and they're looking for 4 other ones, and we can't use that one there. Okay, so what are all the different ways we can rewrite this? If you remember, it's x equals cube root minus 8x squared plus 5. That was one of them. The other one would be x equals all over 8, 5 minus x cubed, and then square root. But this one here has a plus or a minus in it as well. So I suppose I could really write this one too. One other way you might remember is if we just add x to both sides. So you get x equals x cubed plus 8x squared minus, plus x minus 5. So if I got 4 now, and they're all different to the one he gives. Yes. Yeah, so there's 4 of them. Other ones I could have is, if you remember, there was one where you could take the x out here, so you'd end up with, but I think that's the one he actually gives in the example, so I'll just stop there. Probably 4 marks. Yep. 1 mark for each. Okay. 3 now. Find the derivative of log 3x squared minus 5. Okay, well, that's a bit like the first one. What rule do I need here? Chain rule. Because the quadratic is inside the log. So if you remember, the rule is you differentiate the outside, which will be 1 over 3x squared minus 5, and then you multiply it by the derivative of the inside, which is 6x. And that's the answer. Okay. So the next one, f of x equals 3 cos 2x plus pi over 3. 3 cos 2x plus pi over 3. He's probably looking for the period and the amplitude. No. Oh yeah, find the period and the amplitude. And also if it's odd or even. First I'll find the amplitude because there's nothing to find. The amplitude is equal to this number here. The amplitude is just how big it is above and below. And do you remember from semester 1 the formula for period? It's 2 pi over the 2 here. So it's pi then.
What do you mean by the period?
How long one cycle is. The length of it. How long. Now the last part is find out if it's odd or even. And he gives...
Why is it 2 pi?
Oh, it's always 2 pi. There was a formula, if you remember, it was period is 2 pi over b. So he gives us a little hint for the last part. Say if it's odd or even. He says we should expand this. So this is the rule cos A plus b. So it's the formula is cos A cos b minus sine A sine b. Now the way to check if something is odd or even, you see what happens if you put minus on the x. If the minus disappears, then it's which, odd or even? Even. And if the minus can be taken out, then it's odd. So if I put the minus on this, I'd get 3 cos minus 2x. Now, cos pi over 3 is a half. Minus sine minus 2x, and then sine pi over 3 is root 3 over 2. What happens to the minus inside the cos one? Can it come out, or does it change, or what? Is cos even or odd? Even. So that means the minus can be dropped. And what about sine? Even or odd? Odd, so what can I do with this minus? It can be taken out in the front. And you'll notice that this does not equal the original, because there's a minus here and it's a plus here. And also, it does not equal minus the original. So I mean, it's not odd or even. The second way to do this will be to draw the graph of it. If you wanted to, you could draw the graph like how you did in semester 1. So we'll have a quick look at the graph. So remember, for an even graph, it needs to be the same on both sides, and then for an odd graph, it needs to be the same in the corners. Still loading. No, there it is. Okay, can you read out the function to me? What was it? 3 cos 2x minus pi over 3?
Yeah.
Yeah. All right, so let's have plus, okay. You see, it's not even, it's not odd. If it was even, this should be a little bit more to the right. So the answer is correct. And this is if you wanted to do it this way in the exam, I'd give you full marks as well, okay, if you wanted to draw the graph. Okay. Next now, we're given sine, and we're told that A is in the first or the second, and we want to find cos 2A. And we're given sine A is 3/5. So what one is this now? Number 4, is it? No, number 5. So I say sine A equals 3/5, and if you remember, you can say cos A equals plus or minus square root 1 minus sine squared, which is 9 over 25. So cos A is plus or minus 4 over 5. Now if you remember the circle, we're nowhere in the first two. Are we in the first or the second? We don't know, because sine is positive in the first and it's positive in the second. So we could actually be here or here, we don't know. But cos is positive here and negative here. So we don't know if this is a plus or a minus. But I think it'll end up not mattering, because the formula for cos 2A, if you remember it, is cos squared A minus sine squared A. So in fact it doesn't matter if it's positive or negative, it's going to become the same because of the square. So that would be 16 over 25 minus 9 over 25, so the answer is 7 over 25. Find the angle between the vector 1, 1, 1, 1, minus 1, and 1. So that's a straightforward question for 5 marks. 1, 1, 1, and 1, minus 1, and 1. So this is the first vector, and then this was the second vector. And the formula for the angle, you put the dot on the top, which will be 1 minus 1 plus 1, and then the magnitude of the first vector and the magnitude of the second one. Now if I want it in degrees, so theta is 70.5 degrees. And that's number 6 done. Okay. 7 is we need to sketch this, showing where the graph crosses the x-axis. Absolute 3x minus 5 minus 2. A7 now, isn't it? Okay, so we want to find out where it crosses the x and the y-axis first. So firstly, the easy one to get is where it crosses the y-axis. You put x equals 0, and you'll get y equals absolute of minus 5 minus 2, which is 5 minus 2, which is 3. So 0, 3 is one of the points. Then the next one where it crosses the x-axis, you put y equals 0, So you get absolute of 3x minus 5 minus 2 equals 0. So that means absolute of 3x minus 5 has to equal 2, which means 3x minus 5 has to equal plus or minus 2. So you get 3x equals, plus will be 7 and minus will be 3. So then you get x equals 7 over 3 or 1. So 1, 0, and then the other one is 7 over 3, 0. I don't think he asks for the turning point in the graph. Let's see. No. But he does want to know what the range is as well. So that means we should find it. So do you remember how to find the turning point? It's when the inside of the absolute is 0. So how can you make this 0? X equals, 5 over 3. And therefore, y will equal minus 2 if you're making this 0. So there's our last point, 5 over 3 and minus 2.
What is 6 plus or minus 2? 3x minus 2.
Absolute. Remember, absolute of 3 is 3, absolute of minus 3 is 3. So if I say the absolute of x is equal to 5, it means x must have been plus or minus 5. Let me draw the graph of this now. Absolute 3x minus 5 minus 2. X minus 5 minus 2. So this point here we had, this was 0, 3. This one here we had 1, 0. This one here we had, which is 7 over 3 and 0. And then this was the turning point, which was, what did I say it was? 5 over 3 and minus 2. So when you draw the graph, you need to have those 4 points labeled on it to get full marks. So this one here was 0, 3. 1, 0. 7 over 3, 0. 5 over 3 minus 2. And the last thing you want here is what's the range. So if you remember, the range is the vertical values. So what values can you have on the y-axis? Could you have any value or only certain values? Yeah, very good. From minus 2 onwards. Including or not including minus 2? Including, yeah. So the range is minus 2 to infinity. Okay. Substitution to calculate cos x square root 1 plus sin x. Okay. Zero pi over 2 cos x square root 1 plus sin x dx. And what's nice is they tell you the substitution to use here. U equals 1 plus sin x. So that means du dx is cos x. So that means du over cos x equals dx. So this becomes now integrate cos x square root u du over cos x, which is great because they go. So you're just left with square root u a power a half du. Which will equal u power 3 over 2 over 3 over 2, which equals 2 over 3, and u was 1 plus sine x 3 over 2 then. But don't forget the limits here are 0 and pi over 2. Okay, so this will equal 2 over 3, 2 power 3 over 2, and then when you put the 0 in, you'll just get 1, so minus 1 then. And if I want that as a decimal, 2 power 3 over 2 minus 1 times 2 over 3. So that would be 1.22. And then you can check the answer on your calculator by typing the question in again. So it was from 0 to pi over 2 cos x square root 1 plus sine x. Cos x square root 1 plus sine of Yep, same answer. So then in the exam you know that you got full marks on this, which is 6 marks.
How do you check again?
There's an integrate button on the calculator. Do you have 2 calculators, or did I take your one? Oh yeah. I like taking your calculator.
Yeah.
There, at the top left.
Yeah.
There it is. But the way to make the x is alpha x. You all see where it is on the calculator? Yeah? It's helpful because then you know if you got the answer right or wrong. Very useful. Okay. And then the last one in section A here for another 6 marks. So you see those last 3 I did were 18 marks in total. Nearly 2 grades. All right, 32, 57, 25, 82, 54, 37, 29, 47, 65, 56, 32. And what are we looking for? The range, the median, and the interquartile. So pretty much everything. So do you remember what you have to do here? You have to write them from smallest to biggest. And the median is the one in the middle. So if I have 9 numbers, what's the median? It'll be between 4 and 5. So between this one and this one. So you have to add them together and then divide by 2. So the median is 42. So I'll write that down firstly. Yeah, question? Between the 4th and the 5th one, yeah. Isn't it? No, you're right, sorry. If it's 9 numbers, then it'll be the 5th number. 5th number. Isn't it? 1, 2, 3, 4, 5, 6, 7. Yeah, the 5th one, sorry. So that's here. 47. The range is the biggest number minus the smallest number. So this is the median. So then the range is equal to the biggest number minus the smallest number. So that's 57. Okay, now for the lower and the upper quartile, you need to split this into two halves. So the median is 47. So if I can include 47, I should. So there's the first half, and then there's the lower half, the second half. Okay. So with these 5 numbers here, what's the middle of these 5 numbers? Which one? 32. So this is the lower quartile. And then for these 5, what's the middle? 57. So that's the upper quartile. So then the interquartile range is the upper minus the lower, which is 25 here. So IQR is 25. One sec, I just want to make sure I got all this. Range, median, and interquartile. Okay, what are you asking me, Faisal?
There are 8 numbers we take like 4 and 4.
Yeah, 8 numbers is actually easier. It's clearer. Where it's an odd number, the median gets pulled into both. Yeah. Okay. So that's section A. That question there at the end is 6 marks also. So the last 3 questions in section A were 18 marks. Okay. Now, section B. Okay, so write this equation down. Y squared plus 3xy plus 4x squared equals 37. Okay. So B1, A1. So y squared plus 3xy, wasn't it?
Yeah.
Plus x squared?
4x squared.
4x squared equals 37. Okay, and the question is, find the derivative at the point 4 minus 3. So in other words, find the derivative at 4 minus 3. I mean, it's a straightforward example to start with. So this is implicit derivatives. So derivative of y squared is 2y dy dx. Take care here because you need the product rule. So first the derivative of 3x, which is 3, and then the y, plus 3x, and then the derivative of y is 1, yeah, dy dx. That is 8x equal 0. So a little bit of rearranging here gives you y derivative equal to minus 3y minus 8x all over 2y plus 3x. And we want this at the point 4 minus 3, wasn't it? Yeah. Okay, so putting in 4 minus 3. Well, minus 3 times minus 3 is 9, minus 32, minus 6, plus 12. Yeah, minus 23 over 6. That's the answer for that one. Find the normal at this point now. Okay. So part 2 of this question is find the normal. What would be the slope for the normal?
6 over 20.
Good job. 6 over 23. So y equals mx plus c. To find the c, you put in the point. So you get minus 3 equals 24 over 23 plus c. So c equals minus 3 minus 24 over 23 minus 93 over 23. That went in for the y, yeah, and then that one went, no, 12, 24, yeah, that's it. Okay, so the answer then is y equals 6 over 23x minus 93 over 23. And if you wanted to clean that up, although you don't have to, you could write that as 6x minus 23y minus 93 equals 0. Although that's unnecessary. All I did was take the y to the right and multiply everything by 23. Okay, let's have a look now. So that's 7 marks. Okay. So given that y equals x sine 3x, show that. So this is one of these, sub this into this equation to show that it's equal to that term there. So y equals x sine 3x. Y equals x sine 3x. So before I even start, I should get the derivative and the second derivative, so it's ready to put into the equation. So the first derivative here, I need the product rule. So that would be 1 sine 3x plus 3x cos 3x, because you need the chain rule for this part. The 3 comes out. And then the second derivative, that would be chain rule here. So that would be 3 cos 3x, and then this is product rule again, plus 3 cos 3x, and then derivative of cos is minus sine, but the 3 comes out again, so minus 9x sine 3x. But I can add these two together to clean it up a bit actually. 6 cos 3x minus 9x sine 3x. Now if I look back at the question, he wants me to show that the second derivative plus 9y equals to that. So there's the second derivative. And then 9y would be 9x sine 3x. So there's the second derivative, and then there's 9y. And he wants you to show that if you add them together, you get whatever he had in the equation. So what happens when I add these two lines together? What do I get? If I add the second derivative plus 9y, so in other words, if I add these two lines together, what am I left with? Yeah, I'm just left with 6 cos 3x, because those two will cancel. Which is what he has in the question here. So there's 4 marks for that. Okay, the last part in this was solve this equation, x over log y. So if you remember, you have to separate. The left is the y side and the right is the x side. So I get log y dy equals x dx. Okay, so before I go ahead with this question, I can tell you that when the students did this question 2 years ago, nobody in the class got it right. Every single person got it wrong. The reason everybody got it wrong is because the question needed a little trick. A trick that nobody remembered. If you were to look in your formula book, you'll notice that there is no rule for the antiderivative of log. There's a rule for the derivative, but there isn't one for the antiderivative. So what are your options? Well, you could try substitution here, but there's nothing to substitute, right? Because it's just log y. It's not like it's log sine x. So we can't use a substitution because there's nothing to substitute. There's no rule in the formula book. We can't use proper partial fractions because it's not a fraction. We can't use improper partial fractions because it's not that either. So what's the last integration technique that we've not used or I've not mentioned? No, integration technique, integration method. Very good, by parts. But there's no multiplication here. But this is where the trick is supposed to be. You're supposed to say there's like a 1 here in front, and then you can use by parts. This side here is easy. It's the left side that everybody got wrong. And if you remember from integration by parts, L-I-A-T-E, so that means the log should be in the front. So I'll change it to log y times 1 dy equals x squared over 2 plus c, because that's okay. Now, if you remember the rule for integration by parts, you have the f derivative, g derivative. So this is f, and then this is g derivative. So g is y, and then f derivative here will be 1 over y. So the rule is f g minus f derivative g, which is great because then they cancel, equals x squared over 2 plus c. What's the antiderivative of 1? X, but in this case it's going to be y. And then we stop there. I don't think he asked us to get the y. He shouldn't have. No, it's way too difficult to try and get the... In fact, it might even be impossible to try and get the y out from that. Because if you remember, it's quite difficult when the y is mixed inside a log and outside of a log. So that question was difficult. So that's basically 4 marks that nobody got there. Some people got 1 or 2. So these parts were okay. This one here, a lot of people weren't able to get, which I understand why, because it actually was a difficult one, which is all right because it's the last part of the question, so it should be. Okay, 2 now. Describe the transformations and write down the coordinates for that point there, the maximum. -2 and 7. Okay. So this is B2A123. B2A1. So I think the first one here, fx minus 2. Who remembers what this transformation does? Up, down, left, right? Yeah. Move the graph down 2 units. So our example point, he gives us -2, 7. That would get moved to -2 and, sorry, not 9. Move down, so 5. Lowers 2 units. Okay, the next one then is f3x plus 7. So what does the tree do here? Compresses in the x or the y by 3 units. And I shouldn't really say move. What's the verb for moving a graph? Very good. And then translate up 7 units. So then our point now becomes compress it by 3, so that's minus 2 over 3 and 7, and then move it up 7 units. So that's minus 2 over 3 and 14. Yeah. Okay, and then the last one here for this type. 3fx plus 2. It was like that, wasn't it? No, the plus 2 is inside the brackets. Okay, so what happens here with the 3 on the outside? Expand in the y by 3 units, and then the 2 there? Left, yeah. Translate left 2 units. So then our point now, minus 2, 7 becomes minus 2, 21, and then minus 4, 21.
Does it matter which order we use?
Yep. If you have something like y equals a, f, b, x minus c plus d, as long as you take the b out inside here, so it's like a multiplication, you can go a, b, c, d in this order. So for example, never write this. This is no good. You should write it like this. And then if you do it that way, you can go A, B, C, D in order like that. Right. That's 8 marks. Not bad. Okay. X plus 2, and then x squared plus 3x minus 4. X plus 2, x squared, what did I say, plus 3x minus 4, was it? Yeah. Find PQ minus 3 and QP minus 3. Okay, so firstly, PQ minus 3. So do we put the minus 3 in the P or the Q first? Into the Q. So that would be minus 3 squared, which is 9, 9 minus, so it'll be minus 4 in total when you put the minus 3 in here. And then minus 4 goes into the P, minus 4 plus 2, minus 2. And then the other way around, the minus 3 goes into the P, so minus 3 plus 2, minus 1, and then the minus 1 goes into the Q, so that'll be 1 minus 3 is minus 2, minus 4 is minus 6. Okay, so the next part is he wants you to solve PQ of x equals QP of x. So q is x squared plus 3x minus 4, and that's to go into the p. And then the p is x plus 2, and that's to go into the q. So if I put this into the p, remember p is x plus 2, so it'll just be all of this plus 2. And then the more difficult one, if I put this into the q, so that would be x plus 2 squared plus 3 times x plus 2 minus 4. Because remember, for the q was x squared plus 3x minus 4, and the p was x plus 2. And this is the x here, and this is like the x here. Okay, on the left we get x squared plus 3x minus 2, and on the right we get x squared plus 4x plus 4 plus 3x plus 6 minus 4. It's nice that the x squareds cancel. So here I get 3x minus 4x is minus 1x, minus 3x is minus 4x. Then on the right I'll get 2 plus 4 is 6, plus 6 is 12, minus 4 is 8. And then we're left with minus 2 for x. Okay, and then the last part here for 1 mark is find the inverse of p. Px is x plus 2, and if you remember, the way to find the inverse is you solve for x. So here you get x equals y minus 2, and then that's the answer, x minus 2. But if you just think about it for a moment, if I said add 2 to x, what's the reverse of that? Well, the reverse of that would be to take 2 from x. So likewise, if I said px equals 2 multiply x, what do you think the inverse of that should be? Divide by 2. So in other words, x over 2. Or if I said px equals x squared, what would be the inverse? Square root. So it's only 1 mark at the end there. Okay, next now. Integration by parts for x squared ex. Yep. What do you need, the question, is it, or the previous? No, Joseph? But Brendan and Abanoop. Please note, Brendan, he is only here by accident.
No, I meant to say...
No, I know what you said.
No, seriously.
Let me tell him your story. It's a good story.
Okay.
He woke up at 7:40, but he thought it was 8:40, so he rushed to school, and that's why he came early.
No, I came to school at 9, and I thought it was 9, but it was 8. So I went back home, and then I came back 1 hour later.
How far away do you live that you can go back home and go back?
2 minutes away.
So you went back home, back to bed, a bit more of a sleep, and then come to school.
Yeah.
Nice. You didn't want to wait here, no? No. Why were you 1 hour early though? Did you forget to change your clocks or something?
Yeah. No, I didn't forget to change it.
Right.
I changed it, but I changed it wrong.
Alright, okay. Funny. Okay, next now. 0, 1, x squared ex dx. So you have f derivative g derivative. So f is x squared, f derivative is 2x, g derivative is ex, and g is ex. So this becomes fg minus f derivative g. And then when you look at this, you'll notice it needs the rule again. So again, f derivative g derivative, they're still going to be e's. F is 2x, so f derivative is 2. So this becomes x squared ex minus, and then the rule again, fg minus, say who? Late for any special reason? Okay. Where was I? fg minus f derivative g. Okay, now we're finished. Because this equals x squared ex minus 2x ex plus 2ex. And then we have to put in our 0 and 1. So if I put the 1 in first, I'll get e minus 2e plus 2e. And then if I put the 0 in, I get 0, 0, 2. Yeah. So they cancel. Oh yeah, so I'm just left with e minus 2, which is 0.718. And again, you can check that the answer is right on your calculator by typing the original in. Sorry, I'll zoom. Integrate 0 to 1 x squared 0 to 1 x squared e power x. Yep, so you know that you got that one right. Okay, partial fraction one here, but nice is that they tell you what the three parts are. So we have 2 over, so let me write that down, 2 over 2 minus x, 1 plus x squared. Two over, what did I say, x minus 2, x plus 1 squared. Oh no, I have my backwards, should be 2 minus x. Okay. And you're told that this is equal to probably a over that. It's repeated, so we have to do the linear one. Okay. Yeah. We know that normally this one here would be cx plus d, because if this is quadratic, this should be linear. So by doing it like this, it's like they already gave us one of the answers. It's like they told us one of the terms are already 0. So going back here, it's a over 2 minus x plus b over x plus 1 plus c over x plus 1 squared. So you know the deal. You multiply everything by this denominator here, and you end up with 2 equal to a x plus 1 squared plus b 2 minus x, x plus 1, and then c 2 minus x, yeah. Now you can choose any values for x to try and get the a, b, and c. So I will put firstly x equal to 2. And that will leave me with 2 equal to 9a. Yeah? Because that will go and that will go. So I get a equals 9 over 2. Now I think for the next one I'll use x equals minus 1. Yeah. So then I'll get 2 equal to, that's gone, and then if I have minus 1, 2, minus 1, so that's 3, c. So c equals 2 over 3. And then finally I'll just use x as 0. So therefore I get 2 equal to a, which I know, plus 2b, which I don't know, plus 2c, which I do know. So I can get out the b from this. I'll have to double check that, but I got a messy number, minus 23 over 12.
Yeah, I guess,
Yep, okay. So there's the A, B, and C for that. How many marks? 5 marks. And then the last part is to use your answer to integrate from 0 to 1. So last part is, in other words, integrate this answer. So it'll be a, oops, I know a, 9, part 2, 9 over 2, integrate 1 over 2 minus x dx, plus b, which is 23 over 12, integrate 1 over x plus 1 dx, plus c, 2 over 3, integrate 1 over x plus 1 squared dx. The first two are almost like which rule? They're almost like which one? Log, yeah. It's just you need to fix the first one, because what's the derivative of 2 minus x? What's the derivative of 2 minus x? Minus 1. So I'll put a minus and a minus here. Now the derivative of the bottom does equal the top. So this will be minus 9 over 2 log 2 minus x, minus 23 over 12 log x plus 1. And by the way, this one here you could use with a substitution. What would you let it equal? U equals x plus 1. But another way to do it is to write as x plus 1 to the power of minus 2. There's a quick way to do it. Whenever you have something like this, the quick rule is, you increase the power by 1, divide by the new power, and divide by the inside derivative. But that's only a quick rule that you'll probably not do properly. So in the exam you should say let u equal to x plus 1. But anyways, after you say let u equal to x plus 1, you'll get here plus 2 over 3, and then it'll be x plus 1 to the minus 1 over minus 1. Okay, so this is minus 9 over 2 log 2 minus x, minus 23 over 12 log x plus 1, minus 2 over 3 times 1 over x plus 1. And he tells us the limits, I think, were 0 and 1. Yeah. Okay, putting the 1 in first, you get minus 9 over 2 log 2 minus 23 over 12 Oh, sorry, not log 2, log 1, because it's 2 minus 1, which is gone. This will be log 2, and then this will be minus 2 over 3 times 1 over 2. The 2's will cancel, so it'll actually just be minus 1 over 3. And then minus, and we put the 0 in. Oh, need a bit more space. Minus 9 over 2 log 2 minus 23 over 12 log 1, which is gone, and then minus 2 over 3. Okay, so let's clean this up a little bit. Minus 23 over 12 log 2 minus 1 over 3 plus 9 over 2 log 2 minus and minus plus 2 over 3. Okay, 2 over 3 minus 1 over 3 is 1 over 3. And then these can add together. 9 over 2 minus 23 over 12. So that's 1 over 3 plus 31 over 12 log 2. Now, that doesn't seem right. I have the 1 over 3, but I have to simplify this a bit more. I think he wants us, to simplify this a bit more. So what can I do with it? He has 9 in the denominator, whereas I have 12. I wonder if I made a mistake. A is fine, B is fine, C is fine. I wonder if there's a mistake here. Okay. Let me just type this in. 2 1 plus alpha x squared two over 2 minus x1 plus x. Okay, so if I type this in on the calculator, I get 0.64. So let me check that that matches up. 1 over 9 log 16 plus 1 over 3. Yep, it does. That means there's a mistake somewhere in mine here. Avenue, you checked this last one for the B and you said it was right, yeah?
Yeah, I got it soon.
Okay. What I'll do is, if somebody can just call out this 3 parts here. No, call out the 3 parts here with the A, B and the C. I'll type it into derive and make sure that I have the A, B, C right. Okay, so so the first one? What's the first one, the A? What's the A? Just the A first.
9 over 2.
9 over 2. Okay, and then in the denominator, it was 2 minus x? Okay. And then the B?
Minus 23 over 12.
And then the denominator was x plus 1, was it? Okay, and then the C?
2 over 3.
And then x plus 1 all squared. No, so that means something's wrong with my A, my B, or my C. One of the numbers is off.
The B, I did it again, it's minus 19 over 12.
Thanks. It would have been handy now a few minutes ago if you told me that. Are you sure? Let's check it. Can someone else check the B for me here? So if I write it here, the B, I have to put in what the A and the C is. 2 minus,
Isn't it 2 over 9?
for what, the A? Oh, thank you. Problem solved. So that should be
Yeah.
2 over 9. That doesn't affect the C, but it'll affect this one here. Okay? Two minus 2 over 9. All right. I'll wait for someone else to give me the B. B is?
5 over 9.
That's not what I got. Check again. Someone, don't just sit there looking sleepy like you haven't done anything. Come on, check.
Is it 2 over
2
9?
over 9.
2 over 9, thank you. That's what I got. So I just need to change my A and my B. So that should be 2 over 9, and then at the end here, no, here also, 2 over 9. But positive. So this is positive 2 over 9 as well. And then this one here is negative 2 over 9. Two over 9 positive. 2 over 9 here, negative. 2 over 9 positive. And then, well, that's gone, so that doesn't matter. And then here, minus 2 over 9. And here, positive 2 over 9. Okay, so let's add them together again. Cancel. Alright, 2 over 9 log 2 minus 1 over 3 plus 2 over 9 log 2 minus 2 over 3, or plus 2 over 3. So that's 1 over 3 plus 4 over 9 log 2. But you can take the 4 in as a power. So you get 1 over 3 plus 1 over 9 log 2, or 2 power 4, isn't it? 2, 4, that's 16. Yep. Now it matches up. All right.
How do you integrate the last function around?
Which one?
There's a square in the denomination.
Ah, you mean up here?
Yeah.
All right, I'll make a little note in a moment for that. Yes. Okay. There's a quick way, Hassan. If you have something like this, a quick way to do it is increase the power by 1, divide by the new power, and divide by the A. Is a quick way. The way you should do it, the long way, is you make u equal to ax plus b. You don't have to use this. I'm just saying, it's not in the formula book. It's a shortcut. Okay, 4 now. Okay. Write those 2 lines down, please. These 2 lines. got them? Okay, so 4a part 1. Okay, so the first line, I'll put it together straight away as 1. So what was the first part, the IJK part at the beginning?
1, 2, 6.
1,
2.
1, 2, 6. And then what was next? How many lambda i's or whatever?
So, yeah, 1, 1 minus 9. Yeah, lambda.
Yeah.
Then I plus j minus 9. Okay.
So it was, lambda was taken out, and it was a 1 and a
1 and minus 9.
a 1, a 1 and a minus 9. Okay, so plus lambda minus 9 lambda. That was the first one. And then what's the second one? The IJK at the beginning? 4 minus 2 minus 8. And then there was a mu taken out. And what were the...
It's 4, 2.
4 minus 2 minus 8. Yeah. And then the mu was 1 minus 6 and minus 4 plus 4. So there are the two factors. And the first question is prove that they meet and find that point where they meet. So you basically make 3 equations here. You say, well, you can make 2 because there's only 2 unknowns. 1 plus lambda equals 4 plus mu, and then 2 plus lambda equals minus 2 minus 6 mu. So that becomes lambda minus mu equals 3, and then that one becomes lambda plus 6 mu equals minus 4. I'll subtract them. So they go, I get 7 mu equals minus 7, so mu is minus 1. I put that back in there. So that's lambda is 2. And then what you're supposed to do is to put those answers into the equation you didn't use to make sure it works. Although you don't have to do that. I'm just going to put the lambda and the mu back in. So the mu is minus 1. So if I was to put in minus 1 here, what would I get? I get 3 minus 2 plus 6, that's 4. And then minus 8 minus 4, minus 12. And then if I put the lambda is 2 into this one, I get 3, 4, and then 6 minus 18 is minus 12. So you can see that they're the same. This is when I use lambda is 2 and mu is minus 1. So yeah, they do meet, and they meet exactly at that point. So they meet at 3, 4, minus 12. And this happens when mu is minus 1 and lambda is 2. Find the distance OP. Oh, and he says call this point P where they meet. So he wants the distance now from O to P. In other words, he wants the distance OP, which is just the distance P, which, just going to be the square root of 9 plus 16 plus 144. The magnitude on that. 9 plus 16 plus 144, 169, so there should be 13. Yeah. Okay, so that's the second part done. Find the vector of the line which passes through those 2 points. So can you just make note of those 2 points? And we want to find the vector that goes through these 2 points. So 2, 1, 9, 4, minus 1, 8. So 219, 4 minus 18. So what was the first point?
219.
219, and then the second one?
4 minus 1, 8.
4
Minus 1, 8.
minus 1 and 8. So to find the vector that passes through these 2 points, you can use this formula if you remember it. A, if we call this A and B, A plus lambda AB. Isn't that it? Yeah, I think that's the formula I gave you. Yeah, that's the A and that's the B. So it'll be 219 plus lambda, and then the formula for AB, how do you find AB? B minus A, so that would be 4 minus 2 is 2, minus 1 is minus 2, 8 minus 9 is minus 1, and then that's the answer. Okay. So these 2 vectors are perpendicular, find lambda. So if they're perpendicular, what do we know? Dot product is 0. So the first vector, 9 minus 3 and 5. Nine minus 3 and 5, and then the second vector is lambda lambda 3. So for them to be perpendicular, their dot product should be 0. Their dot product will be 9 lambda minus 3 lambda plus 15 equals 0. 6 lambda equals minus 15. Divide both sides by 3. 2 lambda equals minus 5. So lambda is minus 5 over 2. And the last one here for vector B is perpendicular to C. Simplify that. A dot B plus C plus B dot A minus C. So if I write it out here, A dot B plus C plus B dot A minus C. And we're told that B and C are perpendicular. Okay, so here we get A dot B plus A dot C plus B dot A minus B dot C. But B and C are perpendicular, so that means this one goes. But B dot A is the same as A dot B, so they go together, and you're left with 2 A dot B plus A dot C. Okay. 5 now. Five A1, 2x squared minus log x plus 2. So the first thing we're asked to do is show that this has a root between 0 and 1. So first we put in 0, and we see that we get a negative number. And then we put in 1, and we get 2 minus log 3. We get a positive number. So sign change implies there's a root between 0 and 1. And then the next thing he's probably going to ask for is to find the root. He says find the root using Newton-Raphson methods twice. So now we want to find the root using Newton-Raphson method twice. So the formula for Newton-Raphson, we need to also know what the derivative is, which will be 4x minus 1 over x plus 2. So if you remember for Newton-Raphson, the formula is xn plus 1 equals xn minus the derivative goes here. And then the original function, the f, goes on the top, 2x squared. The formula, I'll write it here, is xn plus 1 equals xn minus fxn over f derivative xn. Now, does he tell us where to start? Yep, at 0.5. So our first one is 0.5. So then our x2 is 0.5 minus 2 times 0.5 squared minus log 0.5 plus 2 all over 4 times 0.5 minus 1 over 0.5 plus 2, which equals I got kind of a large number, 0.76. So 0.760. And then I won't bother writing it out again, but you do the exact same thing, except this time you put the number 0.76 inside, and I'll get x3 is 0.708 to 3 decimal places. Yep. Looks like it's it. The true answer, if you do it a few more times, will be 0.705. Okay, so that's the Newton-Raphson one done. That's 6 marks, so that's okay. Now the next one is a volume one. So you're given the curve y equals e to the power of 2x plus 3, and then you're rotating around the axis to make a volume, and you want to find the volume. So if I draw what we have, this is y equals e to the 2x plus 3. Yep. And then between 0 and 1, you rotate it. And you're going to make a volume. So we just have to use the formula here to calculate volume. Pi squared, isn't it pi squared or just pi? I can't remember. Pi, isn't it? Yeah. 0 to 1, and then the function squared. Okay, so opening this up, e 4x plus 6e 2x plus 9. Okay, so we have rules to integrate each of these. The first one will be e 4x over 4, then the second will be 6e 2x over 2 plus 9x 0, 1. So if I put the 1 in first, I get e 4 over 4 plus 3e 2 plus 9. Then if I put in the 0, I'll get minus 1 over 4 minus 3, and then that one there is minus 0. Plus 9 minus 1 over 4 minus 3 times pi. So that works out as 130.6. Now we can check if this is right by typing the original in. So the original was 0 to 1, pi on the outside, and then brackets squared, e power 2x plus 3. Yep, so now you know, again in the exam, you got full marks for that one. So actually that question 5 I just did there, I think that was probably the shortest of the 5. The Newton-Raphson is pretty quick, this volume is pretty quick, and that was really it, really. Nothing else to it. So that would have been, if you were looking at the 4 good questions for that paper, probably this one was one of the good ones. Okay. Because in fact that is the end of the question, 6 marks for that. Okay. Our first thing is to calculate the mean. So what I'm going to do is just copy this table over here. Zero to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 89, and then the frequencies 6, 13, 16, 27, 28, 13, and 7. Okay, so the first thing is the mean. But before I even start, I think what I'll do is I'll put in the lowers and the uppers. What would the upper be for the first one? Yeah, 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, and finally 89.5. And then the lowers will be, the lower is actually the one just before it. It's going to be 69.5. And then this one here, you can see will be 59.5. Now, in the marking scheme, you have the way I see it here is you have 3 choices for this one here. You could say it's 0.5, 0, or minus 0.5. It's not going to be 0.5 because 0.5 means you round up to 1 and we need it to round down to 0. So we could use 0 or... do you mind giving Precious a poke there? I think she's fallen fast asleep. Yep, just a little poke. There we go. So it could be 0 or minus 0.5. But I don't want to use minus because it's sales. You can never have a negative number of sales. So the smallest number I think I can really put in here is 0. Whoops. Okay. Now here is the midpoint. So the midpoint will be the first one plus the second one divided by 2. So there's all the midpoints. Is that a little bit too small? Sorry. Okay. Now I can calculate the mean. So if you remember the formula, the mean is you add up all the data, multiply all the frequency, divided by the total frequency. Yes? So if I go back to here, if I want to make my life easier, I can make another column called XF. So that's equal to, well, here I'll call that X. So that will equal this number times this number. Okay, so now add them all up. 5051.5. So it's 5051.5, and then the total frequency, which will be here, 110. $45.9. Part B is the standard deviation. So if you remember the formula for standard deviation, it's square root. We get the square first, average second, and then here is average first, square second, which we have from this part here. So it would equal square first, average second, minus average first, square second. So all I have to do is find the square and then the average. So I should make another piece here. This can be the x squared, and that's equal to the x squared. And then, just like before, add them all up. And then divide by 110. So it'll be 17316.5625 divided by 110. 157.42. Wait, no. I forgot to do something here. Somebody tell me what I forgot to do here. Very good. I didn't multiply by the f, so I should have another one here, x squared f. So it's going to be even bigger. This one times the f. Okay. So in total it should be that large number, 262,376. Divided by 110. 262376.375 divided by 110 minus 45.9 squared. Square root that answer, and you get 16.7 after all of that. Oh, by the way, I should point out, how much battery do I have here? Perfect. In the exam, it is recommended, and a lot of students actually make this one table at the start of the question for doing all their calculations. So I do recommend that you do this, okay? One table, and you can use it for all the parts. Because then the next part is draw the cumulative frequency polygon. So do you remember for that, we need to put, which goes on the x-axis? The upper bounds go on the x-axis, and then what goes on the y-axis? Cumulative frequency, which I don't have yet, so let me just stick it in here. Cumulative frequency. So do you remember, this just means you keep adding them all up. So what would the first one be? It'd be 6, because that's the first frequency. And what's the next one going to be? 19, yeah. So that's equal to the previous one plus 13, so that should be 19. And then the next one will be plus 16. So anyways, they keep adding up, and you should end up with what at the end? Very good, what you do. So you put these two on your graph as the x and the y. Oops. Insert chart. All right. Let's get this one with this one. Okay. CF. X-axis is the data and the y-axis is the cumulative frequency. Don't show that, show that. There you go. That'll get you full marks. Oh, I shouldn't really say data, I should say sales. Doesn't matter. Okay, and then the final part is use your graph to estimate the median. So for the median, what's the highest point on the graph? It's not 120, we know what it should be. What is it? 110. So what's half of 110? 55. So you go at 55, which is going to be hard to see on my screen here, but if you were to look at it, there 55 would be around about there. So I'd say the cumulative frequency would be around about 3/4 of the way between 40 and 50. So about 47.5. I can actually get Excel to calculate the median, so I'll do that now in a moment. I can check if my answer is right. Let's see. Equals function median. No. Median. Passing through?
Yeah.
Go ahead. Median. Okay, and we'll take, no, we'll leave it, doesn't matter. You can check the answers are on, you have the answers already, don't you? I think the answer in the marking scheme, what they usually, wait, slow down there. The way the marking scheme answer usually works is they say, accept the answer if it's between these two numbers. So I think the marking scheme said accept the answer as correct if the student gives you between 46 and 48 or something like this, okay? So in the exam, you have some margin of error that you're allowed to have for this graph question at the end, okay? So you have, Brandon, so how long do you have to do this exam? 2 hours. And how many questions do you do from section B? 4. I've done 6 questions for you, and I did this in 1 hour and 40 minutes. Okay, so if this was a real exam, I could have actually done every single question and had 20 minutes to sit back and go, yeah. So my point is, you do have enough time if you practice these enough to get fast at them. All right? All right, I will give you a couple of minutes to have a quick look at any project questions. Couple of minutes, quick looks. Yep. I don't know, because the timetable might be slightly changed because we have to do half maths for the intake 2. So I don't know, but I know I have a few minutes now.